In this video, I'm going to show you guys how to train your own AI on your own private data, no matter how large your data is. For example, you can input 12 PDFs, each being 8 to 10 pages long, and the AI we train will be able to parse through the PDFs and output specific knowledge for, the queries that you're seeking. We're also going to explore tool calling. For example, if you ask your agent a specific question and the data in your PDFs is not up to date, the agent can use a search tool, which would be a Google Chrome search, where the agent can go to Google, search, return a query, and output this to the user. So we're going to explore these two kind of baselines, and the data we're going to use these three PDFs, one for diffusion models, one for neural networks, and one for the transformer architecture. We're going to feed these in. They have kind of complex information, a bunch of information embedded all throughout the PDFs, and we're going to feed these into our AI model. And the goal is we're going to ask questions, random types of questions, all at the same time, related to these, and the AI will be able to answer. So let's get started. So first, what we're going to do is we're going to explore tool calling. In my previous video, I had a similar kind of set up where we explored just kind of passing through one PDF. And this, we're going to expand this to tool calling and multiple PDFs, as I said earlier. So if you guys want me to do detailed in-depth tutorials on how to run this, how to get everything set up, starting your virtual environment to get all this running, leave that in the comments below. I'll make some detailed tutorials for setup and how to code, things like that. But to jump right in, show you guys what we're going to be building. First, we have our OpenAI API key. Just import this in here. Copy and paste your OpenAI API key here. Nest async IO. This is similar to what we did in the last video. This is just a semantics based thing. We have a constant loop running in the back of our notebook. This just helps kind of synchronize some things up for us. Now for the cool part, let's go into the tools we have. So we were using Llama Index in our last video and in this video as well. If you guys don't know, Llama Index is a very powerful and strong library that we use. It helps us make agents. It helps with things like adding tools to our agents, retrieving data for our agents, just creating engines for our agents that allow us to set them up in production better. I strongly encourage you guys to go check it out, Llama Index. So to get back to this, so what we're going to do is we're going to define, these simple two tools: add function, which just takes two integers and adds them, returns their sum, and the mystery function, which takes the sum of two integers twice and returns their product. So the idea of this is we're going to pass these two tools into the add tool and the mystery tool, into these, definition variables we created for add tool and mystery tool. Now we're going to import OpenAI. We're going to define our LLM. We're going to use GPT 3.5 Turbo for this video. You guys can use Anthropic's models, Cloud's models, Grok, any models you want. GPT 3.5 Turbo works just fine for this. So what we're going to do is we're going to pass in the add tool and the mystery tool to our response. And when we run this, what happens is, we say a query, tell me the output of the mystery function on 2 and 9. So then what happens is, we take the sum of 9 and 2 twice, 11 times 11, 121. We return that. And the beautiful thing about this is our AI agent knew to call the mystery tool when we specify this. Now, if I replace this with tell me the sum of 2 and 9, this will just return simply 9, 10, 11. Yeah, so this will return 11. And, the same thing. You guys can play around with this. But the main idea is, we have these two tools defined. You guys can add more tools as well for division, subtraction, things like that. And whatever you input it, the AI is smart enough to recognize that, we need to pick this tool over this tool through the query itself. And GPT 3.5 Turbo, our LLM, allows us to, pick between these queries. Moving on, we're going to define a auto retrieval tool using Llama Index. We're going to import our simple directory reader file from Llama Index. Our network's PDF file. We're going to load that in, store that in our documents variable, and then we're going to import the sentence splitter, which will allow us to chunk our document up into chunk sizes of 1024. This will take our neural network document and chunk it into 20 pages into chunks of 1024, store it in the splitter variable. We're going to store that, get our document, call splitter on it, and store that in nodes variable. And then once we call metadata on the nodes, once we print our metadata on the nodes, you guys can see we get all this cool metadata about our file. We get the file name, file path, some citations we have, where it originated, things like that. So moving on, we're going to go and import our vector store index. This is going to allow us to build a vector space to embed our nodes into. This will allow us to kind of call our agent later on specific like context-based questions. So now we're going to create, we're going to import metadata filters from our llama index. What this is going to allow us to do, it's going to allow us to not only kind of chunk by metadata, but it's also going to allow us to get specific data by page number. So for example, if you wanted to, you could ask, what are some of the neural networks discussed on page 10, and that will get more specific data. So here we're going to just ask a simple query: what are neural nets? It's going to output neural nets are interconnected units, processing units that work together. Okay, and then we're going to print the metadata that we used for this. So we used the page 2 for this, and we have all our metadata that we use to answer this. And you guys can see this is pretty neat. It's using the metadata, it's outputting what metadata we used to get this data. This can help in kind of verifying explainable AI, making sure you're getting data from the exact kind of source you need it. This can be added in as a tool, into your AI system to kind of double check, cross check data. Now we're going to define a auto retrieval tool. So what this is going to do, we're going to call this vector query tool. Again, we're going to pass in the metadata dictionary we had. We're going to also pass in the vector index. Now what we're going to do is we're going to pass that into our vector query tool, obviously, and then we're going to define our LLM, GPT 3.5 Turbo. We're going to pass that in. And the idea is we're passing in our vector query tool here. So any question we ask, it's going to only choose this one tool, the vector query tool. So how do neural networks work on data sets? It's going to, the verbose is set to true, so you guys can see how the agent is really working. So it's going to call our tool, vector query tool. It's going to use this query, neural networks, on data sets. And it's going to reference, okay, the data here is from page 1, 2, and 3. This is from our metadata definitions earlier, and it's going to output, okay, neural nets can be trained on data sets to learn patterns, make classifications. You present a training set to it, then it makes predictions. All this, neat output. So that's perfect. Now we move on. We see what metadata it used. It used page 3 and page 1 to output bulk of our answers. So now we can add a summary tool to our vector. We can add a summary tool to our AI agent, and what we'll do here is we'll kind of define this. Useful if you want to get a summary of neural networks. I was testing this out earlier with another document I had earlier, so ignore some of the prompts you see here. This is for another document that I was testing, but let's say describe some of the most popular, some of the most effective neural networks, okay? And once we output this, it's gonna chunk our input, and then it's going to output, something like this. So the networks that use backpropagation are very valuable. Networks benefit from clever weight initialization. So it's gonna output, what you need, to build an effective neural network. You can ask it a question, train it, have some PDF backbone, and then the idea is you or any other user can ask any questions like these. What are some effective ways to implement neural networks, and then it'll tell you, a brief summary, so you don't have to go back through the PDF and access all of that stuff. So here we use quite a lot of stuff to output what we needed. We had information from page 1, page 2, 4, 3, 4, 5, 6. Okay, that's neat. And then now we're gonna just say a general question using the vector summary tool. We're gonna do some tests. So give me a summary of neural networks. Let's see what that outputs. So all it's gonna pass in, okay, neural networks, it's gonna output a summary. Now let's say give me a summary of backprop, right? Let's see if it picks up on the abbreviation, right? Okay, yeah, so it's able to pick up on backprop. We mean backpropagation. Okay. Now let's see what is better. Backpropagation or just doing gradient descent? Or no, that's not relevant. Okay, let's say what is better, neural networks, or let's say like single layered neural networks, or multi-layered deep neural networks. Let's see what this outputs and what tool it calls. So it's going to call the summary tool again. Okay. Okay, so okay, this paper hasn't, discussed single layer neural networks. Let me just put some other type of question. Let's see. I want the tool to call the vector tool. Let's see what we had here where we were calling the vector tool, right? So, okay, how can we train neural networks on large data sets? Let's see. This is probably involving a lot of metadata, a lot of different pages. Okay, it's still going to use a summary tool. Okay. Okay, yeah, you guys get the idea. Basically, what you guys, if you guys test this around with, the neural network stock, I'll put this in the description of the video so you guys can play around with it yourself. But if you play around with, vector tool and summary tool, and you guys kind of test out how this works, you guys will see, that we can pass in both of these tools, and we'll use tool calling to output mainly, relevant outputs. And in this case, the questions I'm asking, I'm not asking too in-depth questions, which would use the vector tool, so it's using a summary tool for most cases. But yeah, you guys get the idea. The cool thing about it, the main idea is you guys can pass in tools. You guys can make other tools too if you wanted, besides the vector query tool and the summary tool. A page retrieval tool where it actually maybe tells you, a tool that kind of combines this to also output, what pages it got this from in the PDF. Like, training neural networks can be computationally intensive according to pages 2, 7, and 8. You guys get the idea. So you can add these different tools to kind of, build on top of your agent outputs to, get better outputs as we kind of iterate and build our agent up. So now we're going to cover something really cool. We're going to add multiple documents to our agent, not just a single document. So to get started, once again, we're going to have the same thing. We're going to import OpenAI. So copy and paste your guys' OpenAI key here from the OpenAI dashboard. Import nestasync.io just to synchronize things. And the papers we're going to use for this are diffusion.pdf, networks, and transformer. This describes diffusion models, neural networks, and transformer architecture. We're going to load those in. Keep in mind, you guys can add, these are just 3 papers. You guys can add 20, 40, 50 papers, each being 100, 200 pages long. The beauty of it is, we're going to be able to embed all of this information in our vector space to make sure that, our AI agent is querying data properly and not putting relevant responses. So we're going to have our utils file. You guys can look at the utils file, but what we just have, get some doc tools. This is the same thing we had from earlier. It chunks up our documents, imports our documents, splits the nodes, everything like that. But we're just kind of putting that in a helper function so we can simplify this here. We're going to import that. We're going to get our tools from the paper, diffusion, networks, and transformer, and then we're going to output, what we have here. Now this line is just creating an initial tools kind of variable for our papers to make sure that, we have all of this here. So we have 6 initial tools for our papers. That's good. So now we have our agent. This is the cool part. So we're going to use GPT 3.5 Turbo for this once again. We're going to define our agent worker. We're going to pass in the initial tools we had on the paper, the LLM on all our papers, the LLM, and we're going to set verbose to true so we can kind of see how our agent is thinking. We're going to define an agent variable with the agent runner. What this does, we can just define agents here with our agent, runner variable. This passes in what we have initially into our agent runner so we can have, better execution. This kind of simplifies things a lot. Thanks to Llama Index, we're able to, represent this quite simply as opposed to, going out on your own, trying to build some architecture for this. So we can ask a bunch of different questions. I've put in some sample questions. What are diffusion models? What are neural nets? What's the transformer architecture? Just basic summary kind of questions. But as you guys can imagine, you guys can put other questions here too. Specific questions that, the AI agent will answer according to what's in these 3 papers. So you guys can take a read at this. Neural networks are inspired by the structure of the human brain. They consist of interconnected nodes and layers. The transformer architecture is based on the self-attention mechanism. It's used in NLP tasks, pretty spot on. So we have diffusion models. Okay, they're applied to kind of general, but yeah, that's what we get. So the main thing about this, the cool thing about this is, you guys can feed this in. You guys can use the backbone of, the agents that we've defined here. The main idea is, the private data you have, the more private data you feed in, the better responses it's going to be able to output here. And the more data you feed in, it's also going to be able to think smarter. It's also going to be able to have more knowledge that it kind of is able to index from and answer, followingly. So if you guys found this video interesting, please give me a like and subscribe on the channel. Leave in the comments if you guys want some more in-depth tutorials on any other kind of topics. Next video, I'm going to kind of go more in depth into other specific type of AI agent infrastructure that people can use. Yeah, I appreciate you guys for sticking through this and watching this. Let me know in the comments how I can improve my videos, and thank you guys.